Hello friends, welcome back to our channel STM Mechatronics, and in this video we will see how to configure the GPIO pin as an input. So for our main agenda will be like configure GPIO port pin as an input. In the last video we have seen how to configure the GPIO pin as an output, right? So like, to configure this GPIO pin, what we will be needing? We will need the data sheet. Second, we will need user manual. Third, we will need some software where we can write the code. So in our case, we have STM32Cube IDE. Okay. And fourth one is a software where we can simulate our output, right? So we have Proteus. Okay. Now from datasheet, we will be able to get like the memory map. Okay. From here, we will get the GPIO registers. Okay, which we should configure to make the GPIO port pin as an output, right? Here we will write our code. Write code, and here we will simulate our code. Simulate the circuit. Okay. Now, first thing first. So for the few things we need to take note of while configuring. Any register, any peripheral register, so while configuring any peripheral register, we must enable the peripheral clock. Okay, we must first enable the peripheral clock. So as we want to use the GPIO port pin as an input, right? First we should enable the GPIO peripheral clock. So this will be our first step. Okay. Second, then configure GPIO registers. Okay. And third, check the output. Okay. So now, so this information we will check from datasheet and user manual. So first we need to check like where this peripheral clock enable option is there. We can enable the GPIO peripheral clock. So what are the bits where we can enable the GPIO peripheral clock? Now for this video what we are going to do is we are going to use GPIO-A port pins as an input. Okay. So we will use two port pins. First GPIO-A pin 3. We will configure this pin as an input. Okay. And GPIO-A pin 1 will configure this pin as an output pin. Okay. So what we will do is we will connect one switch over here. Okay. And we will connect one LED over here. Okay. Now what will happen, like we can do the operation like that. When switch is pressed, right, stop the toggling effect of LED. Okay, and when switch is released, right, toggle the LED. Now this output LED will be an indication. Okay, so first we will check, like for GPIO A pin 1, which needs to be configured as an output, right, output pin. We'll check the resistors. What we will do is, like, this is our GPIO port pin, right, and we will have internal pull up like this. Okay, and we will connect one LED like this. Okay, so this is our LED, right, this is the internal. Okay, this is internal pull up. Register, right, and we'll have the push pull configuration. Okay, so this is push pull configuration. Okay, so like, to configure the GPIO pin as an output, right, we will need these configurations. So first one is output pin, then internal pull up should be enabled. Pull up enabled. Okay, and the GPIO port pin should be in push pull mode, push pull output mode. Okay, output mode, and there is one configuration option, right, regarding the speed. We'll see all these things, okay, while configuring the GPIO port pin. Now we'll write it down in our code. Okay, so we'll come over here. I'll close this, close. Okay, I'll create a separate workspace, switch workspace. I'll create other. _1, or we'll write it as STM32F401 series. Okay, so from here we will able to see like how to create a new project. So to create a new project, first click on file, then click on new, right, click on STM32 project. Some files will be downloaded. Then we will have initializing STM32 target selector. Over here we have to type STM32F401 CCU6, right, because it is the Blackpill board controller. Okay, click on next, give the name as bare metal GPIO input. Okay, then in the options, like, select these settings. Okay, the settings that I am going to do: targeted language C, C++, targeted binary, executable, and over here you change the targeted project type from STM32 to empty. Okay, because we are going to write our own configurations. We are not going to use the configurations which are made by the pin selector. Okay, now you can see that we have the bare metal project, our own bare metal project. Okay, then we have the startup code, the LD file. In the LD file, right, you can see the RAM size available and the flash memory which is available. Then the starting address of the flash and the RAM, it is available over here. Okay, so we'll go into the source, we'll go into main.c. Okay, now what we will do is, here we have main function, right? We'll just loop forever, we'll delete over here. Now here in this section we'll write some code, our own code. Okay, then here, sorry, write the macros needed for our project. I'll go over here, I'll first increase the text size, preferences, the text editor, color and fonts, and edit. Okay, I'll make it as 14. Click on OK, apply. Okay, now we'll write the necessary macros over here. Okay, before, like, we'll have some while one loop, continuous while loop, right? While loop, and after the while loop we should return 0 because it is int main. Okay, so over here what we'll have is, we'll configure GPIO A pin 1 as an output. Okay, then we'll configure GPIO pin 3 as an input over here. Okay, so our first target is to configure the GPIO pin 1 as an output. Now how we can do that? Like, in the starting I have mentioned that first we need to enable the clock for the GPIO A, where GPIO A is residing. So we want to configure the GPIO port pin, GPIO A pin 1 as an output. So our first target will be like to locate where GPIO A is residing, right? Where, what is the memory location of the GPIO A. So that information we can abstract it or we can get it from the datasheet, right? Now if you open the datasheet, right, you can see that we have the datasheet for STM32F401 controller. Okay, and in the memory mapping, right, in the memory map section we have this the bus, the boundary addresses, and the peripheral name, right? So first we will have to check where GPIO A is residing, right? It is connected to which bus and what is the address of that. Okay, so if you can see that, so I hope you are seeing this, the, like, we have different buses, AHB2, AHB1, APB2, APB1, right? And we have different peripherals connected to each bus. So like on APB1 we have timer 2, 3, 4, 5, then RTC, then watchdog, right? Then I2S, SPI2, SPI3, user 2, I2C1, 2, 3, right? On APB2 we have timer 1, timer 8, user 1, user 6, ADC, SDIO, SPI, correct? Then on then on AHB1 we have GPIO, all the GPIOs, then the CRC unit, RCC, flash internal register, DMA1, DMA2, USB OTGFS, which is connected to AHB2, right? And the boundary addresses. So we can look at that the GPIO A or all the GPIOs are connected on AHB1 bus. advanced high bus, right? So the address for GPIO is this. Okay, this is the starting address and this is the end address. Right? So 40020000. This is the starting address for GPIO A. Now, right here, like GPIO A, it is connected to AHB 1 bus, right? The starting address is 0x40020000 to 400203FF, right? So why these many number of addresses, right? So on each address, right, we have 32-bit register. So 32-bit register, right? So if we calculate, we have a number of registers over here, right? Then GPIO B will start from the upper address, like from this 400 address, right? So 0 to 4, so it will be like 7FF, right? So if you check, right, so GPIOB will start from 400 and it will end on the boundary of 400207FF, right? So why these many number, or what are the registers in this address space, right? So we'll go in the user manual. In the general purpose IO section, here we have the register map. Okay. Now it is given that the offset is of 00, and on the 00 offset we have mode register, right? So what it means is, like, we have different GPIOs, right? Now if, like, over here, if you want to explain, right, each address is of 32 bits, right? So 0x4002 till it goes till 3FF, correct? So here we have mode register, correct? Then the second one is offset of 0x04. Here we have output type R. Okay, so I'll keep this same 0004 because each register is of 32 bits, correct? 4 byte, right? So on 0004 we have output type R register. Again, this is of 32 bits, right? Now we'll check like 0008. It will have some different registers. So over 0008 we have output speed R, output speed register. On 0C we'll have, on 0C we have PUPDR, right? PUPDR. Then on, like, 4, if you calculate 4, like, we will have 10. On 10 we have IDR, on 14 we have ODR and BSRR, right? On 0 we have IDR, on 14 we have output data register, 18 we have bit set reset register, 1C we have lock register, 1C we have LCKR, right? 20 we have AFRL, AFRH, right? So AFRL, and on 24 we have AFRH, H, right? Now over here, if you go and check, right, like we have 28 2C 30, then we have multiple resistor, right? It goes till 3FF. So rest of the fields are empty. We should go on AHB1, right, till 3FF. It is used for 3FF, right? But if you go, like, rest of the fields are empty. Okay, only these many resistors are needed in order to configure the GPIO port pin, either as an input or as an output. Okay, now we will go inside each of these resistors and we will decide which configuration bits are to be configured, or which bits needs to be configured in order for the GPIO port pin to be configured as an output. Okay, so this will be our very first task. Okay, now we know that first we will mention over here in our code that hash define GPIO A. Okay, it starts at the address of 0x40020000. This is address of GPIO A peripheral. Okay, now hash define GPIO A mode register. Okay, so I'll add this as base ADDR. Okay, mode register. So this will be this address plus offset of 0U. So offset of 0, offset of 0, right? Now these are the GPIO A registers, okay, that we will define. So we'll mark it like this. We know that for U 8, right? Then we have 12, that is 0xC, right? Then we have 10, 0x14, 0x18, okay. Then 1C, 20, 24, okay. We have till 24 only, correct? We have calculated till 24 we have, okay. So till 24 we have, okay. Now we will rename all these registers. So first one is mode register, second one is output type register. So output type are if you go over here, like we have mode register, mode R, we'll follow the same convention, right? Second one is output type R, third one is output speed, right? So third one is output speed register, output speed. We'll align all these. Fourth one is PUPDR. It is on the offset of 0C, that is 12, PUPDR. Later we have IDR on offset of 10, then ODR and BSRR, right? So we have IDR, then we have output data register, then we have BSRR register, right? After BSRR we have lock register, LCKR, AFRL and AFRH, right? LCKR, AFRL and AFRH. Now we will align all these. Okay. Now we have to give the proper addresses. Right. Here we will give the address of 04. Okay. Then over here we will give the address of 0x8, 0xc, 0x10, 0x14, 0x18, 0x1c, 0x20, 0x24. So in order to avoid this confusion, we'll make it 04, 0c and all these things, right? And over here we'll add it as 0x00. Okay. So we'll again mark this as 0x08, 00, right? 0x04 and we'll mark it as 0x00. Okay. So we have done like this. Now we know that we need to configure these registers, right? So this is input direction and output direction. Input direction is not needed, right? Output data register, sorry, not input direction, input data register is not needed over here for the port pin which is going to be configured as an output. Output data register will be needed. Bit set register will be needed. Lock register, alternate functionality high and alternate functionality low. These registers are not going to be used. So mode register is needed. Then output type register, output speed, pull up, pull down. Okay. So these registers will be needed. Now I have told you already what we need is an output pin. Pin configured as an output. Then the pull up, right? Then the configuration as in push pull, right? Then the speed of the GPIO pin as in low. We'll keep this low, medium, high. We can configure it, right? But for now we need this. We need this configuration, right? So I'll do like this. Okay. Now, first thing that we need to consider is we need to enable the peripheral clock. So this setting has to be enabled, and we need to enable the peripheral clock for GPIO A. GPIO A, right? So again we'll have to go over here, right? Here there is one section, right? Reset and clock control. So we'll have to go over here, right? Then in the RCC register we'll go in the register map. Okay. Here you can see that there are different registers, right? So I'll just go through this. Here you can see that if you expand this, right? AHB1 peripheral clock enable in low power mode register, right? So from here we can enable the peripheral clocks, right? So AHB1 peripheral clock enable register, right? This register is of like RCC AHB1 ENR, right? So we'll go in our code, we'll write, we need to configure this RCC AHB1 ENR, RCC AHB1 ENR register, right? First we will note down its address, offset address. Its offset address is of 30, okay? So its offset address is of 30, right? So we need to add this offset address, right, into the RCC peripheral base address, right? So again hash define RCC base ADDR, right? We have to note it down, okay? So where this RCC peripheral is enabled, right? We'll go into that. So we can go in the data sheet. So we are seeing over here that RCC peripheral is connected to AHB1 bus and its base address is 4002.3800. Okay, so we'll note it down. It is 4002.3800. This is the base address for RCC peripheral. Okay, and RCC AHB1 ENR is 0x30 offset is on this memory location. So the offset for RCC AHB1 ENR is of 0x30 from the base address of RCC, okay, which is this 4002.3800, right? Offset of 0x30, okay. So in this RCC AHB1 ENR, right, in this register, what we will have to do is we will have to enable bit number 0, right? So set bit 0 for GPIO A clock enable, okay. So from where I am telling you this is, like, if you go over here, right, in the RCC AHB1 ENR register, to enable the clock, we have on bit number 0, GPIO A enable, we have bit number 0, right? If you go in the description, here it is mentioned that GPIO A EN IO port A clock enable. So if you write 1 to it, the clock is enabled. If you write 0 to it, the clock is disabled. So we have to write 1 to it, okay. So what we will do is, whatever the previous value is, right, we'll simply write 1 to it. Now the best way to write 1 to it is like to OR this 0x01, okay. So this will enable the peripheral clock, okay. Now like we are performing the operations for GPIO A, like we are configuring both the port pins for GPIO A, right? First pin as an output, second pin as an input, okay. So that's why we have made like RCC AHB1 ENR ampersand 0x01. So it will be written over here, okay. In this memory location it will be written, okay. Then we will go into the, now we have enabled the GPIO clock, right? Then we will go into the GPIO registers, right? The mode registers. Now we want to configure GPIO pin 1 as an output, right? So like there are 4 modes. If we set bits as 00, then it will be in input mode. If we set bits as 01, it will be output mode. if we set bits as 1 0, it will be alternate functionality mode, and if we set bits as 1 1, it is analog mode, right?